but it's going to be a lot less than it was over here. Okay, and you do the same thing again, until you go all the way around until here you have just the one bacteria. Does that make sense? So you're just going to keep going around. Usually you don't have to go around much more than this here, but just for an example, you have to go all the way around until you can separate out just the majority, the one that's the majority of the bacteria. Then you would be able to take this, grow it on a separate agar if you needed, or be able to take it, put it under a slide, and identify it. So this is how you obtain the pure sample, is by going around the agar dish until you've isolated the most plentiful one. Okay. That's what it's trying to show you there on that bottom slide, 286. They started on the one side and they went a little farther over, a little farther over, a little farther over, then they went into the middle once they got the pure sample. Okay. So that's how you get a pure sample for identification. Excuse me. Okay. Other ways you can do that to try and tell if it's what type of bacteria or not is to see how it reacts to oxygen. If it thrives in oxygen, we call it a what?
Aerobic.
Aerobic. If it dies in oxygen, we call it
Anaerobic.
Anaerobic. And then what's the third type? Microaerophil. Okay. Microaerophils do well in low oxygen and higher CO2. Okay. So they're kind of a mix between an anaerobe and an aerobe. Okay. They have examples of each. You will need to know what the examples of each are. You'll need to know that aerobes are staph and streptococcus, E. coli. You'll need to know the anaerobes are your clostridiums, and your microaerophils are campylobacters. And then it's showing you on the bottom of 287 different ways in which you can do swabbing and testing for different bacterium. Okay. Down there on the bottom right-hand corner, you see the one with all the dots on it? What they do is they take a certain bacterium that's looking to find an antibiotic for, and they inoculate the whole plate. So the whole plate's covered in that bacteria, and they stick little dots of antibiotic, little discs of antibiotic on the agar disc, and if it dies or kills the antibiotic or kills the bacteria around the disc, we know that that's a good antibiotic against that bacteria. We call that a clear zone. It's harder to see. I think they have a better picture. Maybe they don't. Yeah, actually have a better picture on 298. So you can see that some of those have little circles around it, little lighter circles. You can get the light just right. Those ones that have the circles in it, that have the clear zone, what we call a clear zone around it, are effective against that bacteria. If there's no clear zone, the antibiotic's not going to do anything. So it wouldn't do you any good to give it to patients with that bacteria. Okay.
Use it again and get it there.
Okay. So you've got this completely covered with bacteria, right? And you bring in some different antibiotics, and you put them in right here. I'll put this one right here, put this one right here. These are all different types of antibiotics. If this antibiotic has what's called a clear zone, that antibiotic is killing the bacteria. So it's a good antibiotic against that bacterium. This one, where there's no clear zone around it, the bacterium's still living, the antibiotic didn't do anything. Okay? So you have some with little clear zones, you'll have some with really big clear zones. Okay? So they really are effective against this bacteria. Or some of these other ones that don't have any wouldn't be effective at all. So we wanna give patients this one, not this one, this or that one. Does
So
that
in
make
this,
sense?
in this picture, basically all of them are, whatever they're testing is working, is effective.
If it has the clear zone around
Because
it.
don't all these though have the clear zone?
Not all of them though.
Not all of them, it's
It's
kinda
like the
hard to
little,
see.
it's like the little white halo thing. Right?
Yeah, a little halo on it. Like the top 3 or 4 have it, but like the 3 middle ones really don't. It's easier to see in your books.
Oh, yeah, barely.
Yeah, it's harder to see. It's
Okay.
easier to see in person than take a picture of it.
Yeah,
It's
okay.
really easy to see
So I was
in
like,
person.
I don't see
Okay.
any, whatever, yeah.
So this would be a very effective antibiotic against it. This would be a semi-effective. So if someone's allergic to this one, you could use this one, but this one wouldn't be any good. You could give it to anyone and it wouldn't kill the bacteria, it wouldn't do any good. So you're just wasting your time. So they can narrow down certain antibiotics for certain diseases depending on these tests. Okay? So do bacterium divide through mitosis and meiosis?
No.
No. Do they divide through sexual contact? How do they divide?
Kind of just pinch off. What's that called?
They just cut themselves in half and boom, 2 cells. What do we call that?
Binary fission.
Binary fission or transverse fission. What do we call the little wall that separates them?
Separates one.
The 2 cells. At the 1 cell has a start. In the eukaryotic cell, we call it a cleavage furrow. Remember, we had this and
Transverse septum?
yes. In a bacterium, you have this little cell that goes like this, it goes like this. And that is called a transverse septum. Pinches off the 2, and guess what? 2 brand new cells. Then what's going to happen to this one? It's going to pinch off. This one's going to pinch off. Pinch off. This is the binary. So 1 turns into 2, turns into 4, turns into 8, turns into 16 as it grows. Okay? That's called binary fission. So if I told you that you had 1 cell, 1 bacterium, and it took it 15 minutes to split, how many cells or how many bacteria would you have after 2 hours? Start with 1. How many 15 minutes are in an hour? 4. How many in 2 hours? There's your 8. Okay. Okay. So if you take this number and take it to that exponent, that'll give you the result. So 2 to the 8th is what? 256, I think.
To the what? To the 8th?
2 to the 8th. That's right. 256. Okay. Or there's another way you can do it. I see a few not quite figuring it out. Get your clock. That's every 15 minutes, right? So 1 I have 1 to to start with. After the first I have, then I have,
4,
then,
8,
then,
16.
that's 1 hour, right? So I'll have 32. $2.56. Easy, right?
Yeah.
All you have to do, which there will be a question on the test that you have to do this. It'll say you have so many bacteria that you start with, and it's what's called a generation time. Generation time is the time it takes for it to go from 1 to 2, or 2 to 4. That's called the generation time. So it has a generation time of 10 minutes. You start with 1, how many will you have in an hour?
That scenario,
Hmm?
16. You have it every 15 minutes, with that scenario right there, you have?
No, every 10 minutes.
So you start with 1 and every 10 minutes
You double.
you double how many you have in an hour.
Okay, so you double after every 10 minutes.
So
So 1 hour is going to give you how many divisions? So you have 6 divisions. So 2 to the 6th is what? Wait, that's 2 to the 4th.
So
2 times
32? No.
2. 4 times 4. 30. 64. 1, 2, 3, 4, 5, 6. That's not right. Let's do it. So how many lines am I going to draw? Okay, so 1, 2, 4, 8. That was her first start. So it'll be 64. Did you get that? So after 1 hour, so it's got to go around 1 6 times. So I start with 1, 2, 4, 8, 16, 32, 64. Shake your head, yes. Shake your head, no. Okay, I don't see any no's, so are we okay?
yeah.
You can either do the clock method, or you can bring a calculator in that they give you. Just go 2 times 2 times 2 times 2 times 2 times 2 times 2. 6 times. Or 8 times, or 10 times, or whatever it is. There's one like that on your study guide, and there most likely will be at least one on your test. Most likely. Okay, so be able to figure out how binary fission works.
Do we have no lag phase and log phase?
Yes. So let's talk about the different phases of the curve. It's a bell curve, right? The smart people, the dumb people. No, that's not what I was talking about. So you have this area, it's going to say A, B, C, D. What is the A? Lag. What's occurring in the lag phase?
Setting up.
The setup, the ramp up, the getting ready to divide, getting all the nutrients, getting all the cytoplasm, getting everything they need all built up. Then what's going to happen? What's this one called? Log phase. Why do we call it log phase? Logarithmic growth, exactly. Logarithmic growth. 2, 4, 8.